Okay, so I'm stalling because I'm super terrified. My name is Henrik, and I'm here to talk about game development. And I have no idea what you want to hear. So I will just jump into a bit about me, what I've done, and what games can be, perhaps. So I went to Chalmers here in Gothenburg, and I left school 22 years ago, and I had absolutely no idea what I wanted to do. This was basically me, and what was more troublesome was that I had no idea of what I actually could do. I have been playing games, and I've been programming some online multi-user dungeon game slightly. I could a bit of C, but I had no idea what I could do. So through a friend, I got my first programming job. A company here in Gothenburg asked me, or they needed someone who could program C++. So I got the question, do you know C++? I said, yes, of course. And they said, you start in 2 weeks. So that gave me 2 weeks to learn C++. And the company in question was Bingolotto. So I made weird televised games on a late night TV show that no one ever watched unless you were very drunk. But my first ever Java application that I wrote in JDK 1.02 was the program that showed the winning numbers in Bingolotto. So my first Java program had 4 million viewers live. You don't want file system missing exception in that time. That was terrifying. But that's all right. I was 24 years old or something. That's how, I was experienced. So basically what happened was that through lying and some sheer luck, I had become a game developer. All of a sudden, I knew I could do something. And so I am a very privileged man. I love what I do. And now, I'm very happy to be here. I'm terrified, but happy to be here to talk about game development. So my first kind of question is, what kind of developers do we have here? Can I get some, you can get some exercise now with stretching your hands. And does anyone code in the other Java language, the script language, the JavaScript? A few? Oh, no, that's plain. Ooh. So, but you're mainly Java purists, I assume. Okay, as I said, I haven't done that since Java. Well, I think when Swing came, I think it was 97, the Swing set user interface thing. That's when I left Java development. So if you want to talk to me about stuff, you can reach out to me on the Twitter handle. It will work through, you can reach me through Twitter or Facebook or, I use that for my GitHub as well, but that's only some Flash game stuff, so it's not so interesting maybe. Even LinkedIn, the saddest of all networking sites, will work. So, and as they say, my DMs are wide open. But I want to talk about things that challenge all of us. Like, game development might sound very different from whatever it is you do. I don't know what you do, so please don't get upset. But I think that there's more that unites us as programmers and developers than it is that separates us, makes us different. So I want to talk about what unites us, what experience and perhaps even wisdom we can share and learn from each other. And also what I kind of want to know is, what can I learn? I want to learn stuff. So I learned a lot about logging and exceptions and weird Java enums from the previous talk, which I liked. And hopefully I can teach you something, or you can find some nuggets that you like here. And I will learn from you. also what makes you angry, because I tend to think that that's what unites us most. Whatever language you program in, it makes you angry at times, or whatever environment. So I think that we should share ideas, share knowledge, and so I'm very happy to see this kind of meetup here in Gothenburg. I haven't been here before, and obviously you're battle-hardened Java meetup guys and girls, persons. So talk to me about anything. I'll be here, maybe even for the beer afterwards. So my backstory, I will go through that very quickly. I've done games. I started making real video games after Bingolotto. I worked in Dallas at a company called Ironstorm, which got a bit famous for a while because it was all kinds of crazy. I made the game Anachronox, that's a gaming gem that nobody played. And this is it, my all-time favorite game, the best video game story I've encountered. Those are actual internet quotes, so it's all true. I worked with the guys who invented Doom, or made Doom at id Software, so I worked with famous people. I also worked at ABB, which is also famous, but the diametrical opposite. It's very large and kind of boring in Swedish industrial company. But we made some 3D robotic simulator software for them. And now I'm at Ghost, working on Ghost Games here in Gothenburg, a part of it which has that kind of logo. And we've been around here for 6 or 7 years. And we're part of Electronic Arts, which is a very large 10,000 person strong company. And Ghost Games has 3 studios, one in Guildford in the UK, one here in Gothenburg, which is the large one, and another one in Romania. And we also collaborate continuously with people in Vancouver and Los Angeles and San Francisco and Japan and Shanghai and India. So the sun never sets on our game development empire. So we just released Need for Speed Payback this fall. And we've done that game in a couple of large number of installments over the years. It started in 1994. It hasn't always been in Sweden. Only the last 3 games has been made here in Sweden, here in Gothenburg. But I'm very proud to be part of that team. And as game developers, we aim to entertain, to challenge and inspire our audience. So it's pretty tricky because people spend a lot of time in games. And that's one of the aspects that we have to consider. People pay to play our games, they pay to be entertained, and they want to be able to spend around 20 to 50 hours in our games. And it's a challenge we take quite seriously. And so I'm very dismayed when my friends tell me that you work in video games, this is what you do at work. And we goof around, maybe a little bit. But what society thinks we do as game developers, as game development kind of becomes famous, it's because of large amounts of money. This is Notch, the guy who did Minecraft. He's a very humble guy. and he that was obviously made in Java, so that's that's fitting for this group. Game development in Sweden is very large. We have a lot of successes like Minecraft and Battlefield and Candy Crush. The Division is made in Malmö, Need for Speed, and Battlefront, obviously, the Star Wars games. And we have around 5,000 people in Sweden doing games, over 300 companies, and close to 2 billion euros in revenues for those who counts the beans. So you can click. And of course, what I think I do is something like this. We're very tough, we're very hard, we do a lot of difficult stuff in short amounts of time. We work very hard, we're super tough. Maybe not, but And I'm concerned that you think that this is what I do. So I'm a bit scared of speaking here. But if you've heard of Joel points, we're not just playing in the sandbox. We're fulfilling 11 out of 12 Joel points at Ghost Games, and extra free juice for someone who can name the missing Joel points. Has anyone heard of Joel points? Yes. The missing Joel point here is: do you fix bugs before writing new code? And I don't understand that one, because every individual game developer does that. Every programmer, before he checks in, is obviously test his code, right? We run some tests, but since we're so many people, we can't stop for fixing bugs. So 11 out of 12 is still pretty good. So what do we actually do as game developers? How does the sausage get made? I think that there's really no difference. We work in pretty much exactly the same way as you do. So we're all friends. There might be some slight differences. Basically this is our life and death. We need to hit a 16 millisecond per frame, or we've done something wrong. So we have every frame we show for the player, we have 16 milliseconds to do all we need to do each frame. So people hunt for frame rates, and this is 16 milliseconds will give you a frame rate of 60 hertz on an updating screen. And many people want more, and everyone wants more. But 16 milliseconds is what we are absolutely aiming for. If we can't beat that, we have to keep working. And for VR, if anyone has done any VR work, you're probably aware that you need to hit this for both eyes, so you get twice the frame rate. There's some cheating thing going on, but anyway. So during these 16 milliseconds, this is what we do. We start off with process input. What has we received from the disk, from the network, from the player? What kind of keyboard input? We update the entire game. We draw it on the screen, and then we return. Do it again. So this is a simplified image. So 22 years ago, we wrote our games in straight up C++. And today, that's pretty much impossible. There's so much stuff needed to get a game out. So we have engines that helps us, toolkits, frameworks, whatever you want to call them. We call them engines because that sounds very powerful. So Unity, may have heard of, Unreal Engine, CryEngine. Our own EA engine is called Frostbite. There should be some more on here. I added the little Starling button because it's a Flash engine that I've been working on as well. Contributing to, I should say, for 2D games. So this is basically similar to Java frameworks, and I just Googled this yesterday, so I'm sure it's out of date by now. That there's a lot of stuff that we use when we usually, the thing that we do the same is that we pick, for a project, we tend to pick one or maybe 2, 3 of these, and we don't really want to change mid-project, I assume. We do the same. We don't want to change game engines in the middle of a project. That's terrifying. And also for those who do JavaScript, I did a bit of a Google for JavaScript frameworks as well. And yeah, I'm sorry. I'm so sorry for you guys. That's scary. So what makes games different? One thing that springs to mind for me is interactivity. And maybe those who make web pages will not agree with me, because apparently there's some interactivity going on web pages. So maybe that's not necessarily a big difference. People who make server jobs, like larger, like build farms and stuff like that, there's a certain level of interactivity, I guess, that you want the builds to finish quickly and stuff. But it's not necessarily real time. You're okay if it takes 92 seconds instead of 95 or something. But during these 16 milliseconds, we need to do this. We basically do this. We get input from the player and we load new objects from the hard drive. We run the enemies, so we move objects in 3D space. We perform physics and collision detection on most of those objects. We run the gameplay rules. We award score if you hit something. We load plays and play sounds in the 3D world to get get a proper mix down of left and right. And we draw all of that to the screen. And for those who do multiplayer games, online games, there's more stuff that has to be taken care of. Receive and process data from the server, predict movement from other players, send movement data back to the server, voice over IP chat, telemetry, etc., etc., etc. So to help us do this, we kind of set up a budget. We take those those luxurious 16 milliseconds and divide them into chunks. And we say that, okay, input processing may take, what is that? 1 millisecond. AI has, luxurious 3. Physics 2, maybe. Gameplay, a bit more. Server, communication, and disk I/O, and then we render. We let the graphics system get a few extra milliseconds. And then we start all over again. So the budget is basically how much time me as an AI programmer, I work there. And that's my slot. That's if I exceed my budget, I get slapped down. I get slapped down quite a bit. So much stuff to do. Luckily, we have CPUs with multiple cores. So we can do, a lot of stuff. This is me playing Civilization 6. I tried to get a solid load, and it's pretty impressive. It does load sharing very well. I didn't expect that. You can see the first thread probably takes the rendering hit. So there's a bit of more CPU processing going on there. The other CPUs seem to be fairly, they share their load very nicely. So, what's in a game? Normally, everything is placed in a 2D or 3D world. We saw an example of a enum used for, was it Minesweeper? Yesterday, earlier today. I haven't been speaking that long, I hope. So everything gets a 2D or a 3D coordinate. We tend to use floats rather than ints or enums for movement. So we get, the math gets much easier and we get a lot more, a softer movement when we move things around. I'm so sorry. And then we need to cut down on the amount of stuff that the CPU has to do. So we create this, what we call a view frustum, or a clip space. Basically, we have a camera. This is you, and you look into the screen like this, and we see this object is within this frustum, this square cone, so that object gets extra care. Stuff that's outside of this box or this frustum is not rendered, so we don't care as much about that. We still have to do collisions because things can bounce around, of course, and enter the frustum. But we don't have to watch it. And to get anything fun on the screen, oh, come on. No? Yeah, I'm awesome. I'm going to do, this was terrifying. Stop that. This is the file system not found exception in my Bingolotto show. All right, let's see if we can do F6. Come on, Shift F5. Yeah. Okay, so this box is a square. It's not so pretty. It's programmer art, just But we want to have some prettier stuff on the screen, so we hire an artist to do a very realistic-looking human like this out of triangles. Or this is quads, but imagine them being triangles. A quad is 2 triangles, and this looks fine at a distance, but we have to have different versions of this. If I get very close up, I need a finer mesh like this to make it look good. Call that level of detail. The further away, the coarser the mesh we can display. And then we have this to make it look very human. Basically, this is the 2D graphics that will be wrapped around the player figure through what's called UV coordinates or texture coordinates. So when this model is modeled, each vertex, each point, each intersecting point will have texture coordinates that corresponds to a ridiculously flat stomach or very green eyes or something, hands. And that gets applied around the texture. And that makes things look very nice. So basically, if we finally get some kind of code on the screen here, the mesh is basically an array of vertices. And each vertex, each intersection on that mesh has an X, Y, and Z coordinate. And a U and V coordinate, which is the mapping on the texture that I just showed you. So this is basically it. To speed things up, we put a bounding box around it to be able to do the view frustum culling that we talked about earlier, the rectangular cone. And that has a min values and max values representing the axis-aligned bounding sphere of that mesh of the object. And then there's normals. And then there's more to it. There's a lot of stuff. There's so much stuff that goes into that, but that was basically the data structures that are being used for drawing things on screen. And there's a lot of math and a lot of data being loaded. So what I do is, in Need for Speed, I do AI, which is basically how your opponents drive and how we do routing in the game. Has anyone heard of Dijkstra's algorithm or A-star searches? Awesome, you can do my work. That's basically what a lot of this stuff is. Finding an optimal route that will look cool and be challenging for the human player to play against. And then we have to consider things like if the car is supposed to be wet, if the road is supposed to be wet, torque, horsepowers, the engine powers, all that stuff. So we do a lot of that. The gameplay aspects will then say, oh, you're driving this fast, you will get these kind of points. This is the amount of time it took for you to finish the race. How close did you drive next to the other players? Did you get extra score for being wild and reckless, or did you drive like me, carefully and considerate and no honking? And then the renderer will kick in and just basically place all the meshes. That's a couple of meshes. That's another more couple of meshes. That's four quads and a texture, etc. So my question is basically, is this different or is it just more? And I believe that we're just doing more. I think we press things harder and we're a bit more focused perhaps on performance. We do time measurements all the time. If we can't measure what we're doing, we're working in a black box. And I think that might be one of the larger changes or the differences. But I think that everyone should be fairly obsessed about doing performance measurement and optimizations to some degree at least. Basically, we want to be able to do more faster. Or we want, if we make phone apps, we want to be able to save battery life by doing less. Getting good performance is just about doing less. And we want to be able to keep server farms smaller. We don't necessarily need 10 blades if we can optimize our code to do it in, I don't know, 10 blades. That's tiny, isn't it? That's like I don't know anymore. It's all Greek. But or you might be able to eliminate the need for a hardware upgrade. And I kind of wrote this, and I thought, well, didn't Apple just admit that they were just, fooling people? People just need to upgrade their hardware anyway. Anywho, so performance will lead to a smooth experience, which will lead to a happy user. And that's the end goal of all performance work. A happy customer, a happy consumer, a happy player, a happy programmer, if you're making a compiler or something. So we kind of touched upon this briefly in the previous talk. We need to measure. We need to measure time to know what's going on. We shouldn't be. We should be afraid of the dark. I'm assuming, I'm going to ask a question so you can stretch your arms a bit. How many do nightly builds in your projects? Do you do automatic testing? Do you do, functional tests? I'm not sure how, that's a bit different. I don't even know the different types of tests. I'm useless. Unit tests or functional tests? Do you test for performance? That's awesome. Basically, what happens is that if your software just got 150% slower overnight because of something someone checked in, you need to know that very early on. Otherwise, that will just fester. So if you get some performance tests in, you should know the problem at 9 a.m. the morning after. So know what's going on. You need to profile your code. Any software system, any build system, any runtime will come with profiling tools. I'm pretty sure of it. Use them very well. Use them a lot. Don't assume you know anything about your code. Measure, measure, measure. Otherwise, you don't know. When you do know, you can attack it and find the hotspots. And I will give you some examples. I was lying before when I said that last time I did some Java work was in 1.02. I actually did a brief look at a server that had high load at a previous job. So this was the assumption. This was serialization coming in, a packet coming in, and some database access, and there was some state that needed to get serialized up from the database. And then something with the game logic that was running on the server was assumed to be very expensive. So they asked me to look into it. And with all my skill in Java, I was looking at the usual suspects. Poor code, poorly, if someone chose a list instead of a set, and all those things. Those people. But so I couldn't find anything. It looked nice. Looked pretty cool. So the servers were running hot, and we couldn't understand why. So I asked for more detail. And we added logging, and of course, strings. Serialization is strings, and poorly used string builders will get you killed. So basically what happened was that we did the actual logic was trivial, very fast, but the serialization up and down to an object that was stored in a database, or to a stream that was stored in a database, was super expensive. So, lesson behind that is if you're using string builders, things are not necessarily super duper fast anyway. You have to use them right. And how do you use a string builder right? I don't know. You need to measure. This is one from today. I'm doing some scaling work. Actually, I'm just adding traffic cars basically to the game. This is our default state. We run like, I'm saying 20, but it's not necessarily 20, but ish. 20 traffic cars at the same time in the world, and performance looks like that. And as I'm scaling it to 200, I was kind of hoping that I would get one section that looked like that, because that's easy. That you can find one piece of the code that takes all the time, and you can focus your energy on that, and you can beat it down, and you can win, and you can celebrate and become the hero of your coworkers by just killing off this like this, right? That would be nice. Unfortunately, things look like this. Death by 1,000 cuts. And it's like, yeah, I want to go to Java Forum. So yeah, so basically this is what happened. We some part of the code takes a little bit longer, or takes some time, and it just basically scales with the number. It's not much. Nothing is really wrong, but we can tell. I mean, it's not really right either. So I got some work to do. Another thing. This is the HTML5 for mobile. I'm not sure if there's anyone doing JavaScript on Canvas. But basically what happened was that they had a fill rate problem. The graphics were taking too long to update. And they did first they did a clear rect of the entire screen, fill it with black. And then they draw the background image on top of that black area. And that's half your fill rate right there. You just drew the same thing twice. Maybe this might be optimized better now, that the clear rect might be faster, but it used to be terrible. But you have to measure. When I was making games at Bingolotto, it took me 2 seconds to do this, to do the clear rect, or to just any one of those, just to fill the ISA bus that we used was so slow. It took 1 megabyte per second. Took 2 seconds to fill the screen with graphics. Awful. So basically, know your platform. Getting a deep understanding of how the garbage collector works is very, very important. And so basically, I'm sorry, I didn't catch your name, the previous speaker. Yeah, Simon, like you said, you're thinking this is brand new information, right? We already know this. Performance is important. We measure. We do all that stuff. You're not saying anything new. You're useless. And so I'm trying to find ways that game development can be considered unique or different. And there's really no difference that makes a difference between us, I think. Maybe we work in a different type of team structure. So I'm over there. This is me. Slim and slender, working with a lot of other types of people. It's not just programmers, there's concept artists and graphics people, sound designers, testers, producers, narrative people. We have a very varied team. But I'm thinking that if you do web development and you provide content, you probably have a fairly varied team as well. So maybe there's no difference. One thing that we do a lot of is that we're trying to make sure that we have inclusivity and trying to employ as many people from different cultures and different backgrounds as possible. But everyone does that. Some of my best friends are C# programmers. I kind of like it. But maybe the difference is that we make entertainment. Maybe that's the main difference. I'm assuming that many of you make things that save lives, trigger alarms in hospitals, or dispatches cops to and firemen to difficult things. We make entertainment. It's a luxury. People do it in their pastime. We choose to see it that people, they choose to spend their time playing our games, and that makes me very happy. But in the end, we make entertainment and we're not saving lives. It's just fun. So come work with us. It's pretty awesome.